Hello everyone, I welcome you all to my channel. So in today's video, what we are going to study? So we are going to study about damped forced harmonic oscillator. Okay, so in the previous video, we have studied about damped simple harmonic oscillator. So if in case you have not watched that video, so firstly make sure to watch that video क्योंकि बहुत सारे concepts ऐसे होंगे जो relatable होंगे. Okay, so that's why make sure that you are going to watch that video first. Later on, we'll move on. Later on, so basically, you can move on to this video. A simple harmonic oscillator, क्योंकि इससे पहले वाली video was related to damn simple harmonic oscillator itself. In that, we studied that X was so the relationship, or we can say that okay, when we got the solution for second order differential equation, that was equivalent to X equals e raised to the power minus RT A E under root of r square minus omega naught square times t plus be negative of r square minus omega naught square times t. So basically हमें इससे क्या पता लगता है? So we know one thing, we get to know one thing that जो इसका solution है displacement का, it depends upon two factors. First one was damped coefficient, which is r. And second one is initial frequency. We can say initial frequency, which is omega naught. Okay, so if in case you have not watched this video, so make sure that you are going to watch it because like the topic that we are going to study, which is damped forced harmonic oscillator. So that is also related to this damped simple harmonic oscillator because we are going to use some of the concepts that I explained in that video. Okay, कि कहाँ से कौन सा concept आया था. So now let's start with damped forced harmonic oscillator. Okay, so now we know one thing कि हमारे पास restoring force क्या होता है? Restoring force हमारा किसके इक्विवेलेंट होता है? So we can say FR is equivalent to minus of KX. That's what we studied. Okay, and similarly हमारे पास जो damping force होता है, damping force. So, okay, damping force, let's say we denote it with FP, so that is equivalent to minus of lambda into V. So this part I have explained you in damped simple harmonic oscillator. So make sure if in case अगर कोई भी doubt है इससे related, then you can surely watch that video first. Okay. So अब अगर हम damped forced harmonic oscillator की बात करते हैं, तो damped forced harmonic oscillator हमारा वो oscillator होता है जिसमें हमारा amplitude एक बार क्या हो जाता है, तो एक बार हमारा nullify हो जाता है. तो उसके बाद हमें क्या करना पड़ता है? हमें एक एक्सटर्नल पीरियोडिक फोर्स को अप्लाई करना पड़ता है. एक्सटर्नल पीरियोडिक फोर्स वी नीड टू अप्लाई, then the body will start moving, that too with constant amplitude. ठीक है, उसके बाद वो कांस्टेंट एम्पलीट्यूड के साथ मूव करना स्टार्ट कर देते हैं. नाउ आफ्टर दिस, तो हम क्या यहाँ पर कंसिडर करते हैं कि जो हम एक्सटर्नल पीरियोडिक फोर्स लगा रहे हैं, एक्सटर्नल पीरियोडिक फोर्स. ओके, सो हम इस एक्सटर्नल पीरियोडिक फोर्स को कंसिडर कर लेते हैं दैट इट इज डिनोटेड विद Fp एंड Fp इज इक्विवेलेंट टू F नॉट साइन Pt. ओके, सो F नॉट हमारे पास क्या है? F नॉट इज द एम्पलीट्यूड. Okay, so this is going to be the amplitude itself. So, if in case we have to tell about the total force, so what's going to be the total force? So, total force will be equivalent to, we can say F will be equivalent to minus of Kx minus of lambda V plus F naught sine Pt. Okay, and since we know one more thing that F is equivalent to MA, MA means M d square x over dt square. Okay, so now let's substitute the value. So that means we can say md square x over dt square is equivalent to minus of kx minus of lambda v plus f naught sine pt. Okay, now let's just like यहाँ पर अब हम क्या करते हैं? Let's just substitute the value for this v also. Okay, so from here we can say this implies md square x over dt square is equivalent to minus of kx minus of lambda. So we can say dx over dt plus f naught sine p t. अब अगर if in case we have to rearrange this, so we can simply write it as so m d square x over dt square plus kx plus lambda dx over dt, and this will be equivalent to what? F naught sine, so F naught sine p t. Okay, so now after this, so can we rewrite it like this? So this implies d square x over dt square plus k over m into x plus lambda over m into dx over dt is equivalent to F naught sine p into t. So from here we can also say that this, so this let's say that here k over n is equivalent to omega naught and lambda over m is equivalent to twice of r. Okay, but here we are left over with one more m that is going to come in the denominator of f naught. So from here what we can say, let's say that this f naught and f naught over m is equivalent to this f naught. Okay, so now अब यहाँ पर हम करते हैं values को substitute. So this implies, so from here we can say d square x over dt square plus omega naught x, omega naught square basically. We also, okay, if you remember in the previous, so in damped simple harmonic oscillator also, we considered one factor that, okay, so what we considered that k over m is equivalent to omega naught square. Okay, so we can say it's going to be omega naught square x plus lambda over m is 2r dx over dt, and this is equivalent to f naught sine of p into t. So now यहाँ से ये हमारी क्या आ गई? So we can say this is the differential. So this is second order differential equation for damped forced harmonic oscillator. और कभी कभी ये डायरेक्टली ऐसे भी आ जाता है कि okay, forced harmonic oscillator. If in case they are not going to mention the damped forced harmonic oscillator, so it means the same itself. Okay. Now after this, if in case अब अगर हमें इसका solution निकालना, solution, okay, अब अगर हमें इसका solution निकालना है तो यहाँ पर हम consider कर लेते हैं let x be equivalent to a sine of pt minus theta. Okay, so obviously अब हमें values को इस equation में substitute करना है. Let's call it as equation number first. Okay, so अब यहाँ से हमें dx over dt भी calculate करना पड़ेगा and then हमें d square x over dt square भी. So what we can say, dx over dt will be equivalent to what? So that will be pa. So sine का differentiation cos pt minus theta. So I'm not writing each and every step. Each and every step means I am not writing like this, that okay, differentiation of a sine pt minus theta. So that is self-understood. So यहाँ पर इस step में हमने क्या कर दिया? Differentiation. Similarly, we can say d square x over dt square. उसका differentiation क्या हो जाएगा? Cos का differentiation is negative of sine. So we can say it will be p square negative of a sine pt minus theta. Okay, so यहाँ पर theta क्या है? So theta basically हमारा phase difference है between this. So we can say here theta is the phase difference between displacement and applied force. And applied force itself. Okay, so अब ये वाली values को हम substitute करते हैं. So what was our equation? So the equation that we got was d square. Okay, let me write it down to the mains. So that was d square x over dt square plus omega naught square x plus 2r dx over dt, and this was equivalent to f naught. So not this one, f naught. So we can say, so that was small f naught. Okay, so here we can say it was f naught sine p t. Correct? So अब यहाँ पर let's just substitute the value. So from here what we can say, अब हमने d square x over dt square की value को calculate किया था. So that means we can say, so this implies it will be minus of p square a sin pt minus theta प्लस ओमेगा नॉट स्क्वायर एक्स की वैल्यू कितनी है a sin pt minus theta plus 2r. So dx over dt is p a. You can say so. It was cos pt minus theta. Okay, and this was equivalent to what? So this was equivalent to f naught sin p into t. ओके सो अब यहां से हम देखते हैं क्या क्या चीज को हम कॉमन ले सकते हैं. सो कैन वी टेक इफ इन केस वी वांट टू कंसिडर कैन वी टेक ए साइन pt माइनस थीटा इज कॉमन. किस किस फैक्टर में से? सो बेसिकली वी आर गोइंग टू टेक इट कॉमन फ्रॉम ओनली टू फैक्टर्स, ये वाला फैक्टर एंड दिस वन फैक्टर, एंड देन वी कैन राइट इट लाइक दिस आल्सो ओमेगा नॉट स्क्वायर माइनस ऑफ p स्क्वायर. ओके देन आफ्टर दिस प्लस 2 r a p cos of pt minus theta, and this is equivalent to f naught sin of pt. अब अगर हम sin of pt को ऐसे लिख दे that okay so it is minus theta plus theta, is it going to make any change? क्या ये कोई चेंज करेगा? कुछ भी चेंज नहीं होगा इससे, करेक्ट. सो कैन वी राइट इट लाइक दिस ऑल्सो? सो इन दैट केस इट विल बी इक्विवेलेंट टू एफ नॉट. यहां से क्या हम ऐसे लिख सकते हैं? सो इट विल बी एफ नॉट साइन pt. सो बेसिकली यहाँ पर हम क्या कर देते हैं, हम इसको ऐसे करते हैं. ओके सो दिस लेट्स कंसिडर दिस इन द स्क्वायर ब्रैकेट इटसेल्फ. सो यहाँ पर अब अगर हम फॉर्मूला लगाएंगे, सो फॉर्मूला क्या हो जाएगा? साइन ए प्लस बी का. सो दैट इज साइन, सो वी कैन से एफ नॉट साइन pt माइनस थीटा cos of theta plus f naught cos of pt minus theta, then sin of theta. करेक्ट. सो अब सिमिलरली अब हम इसे ऐसे भी लिख सकते हैं. सो और वी कैन ऑल्सो राइट इट एज और ए साइन ऑफ pt माइनस थीटा. सो ओमेगा नॉट स्क्वायर माइनस ऑफ p स्क्वायर प्लस 2 r a p cos of pt minus theta. So basically left hand side as it is, and this will be equivalent to, so that will be f naught sin pt minus theta pt minus theta cos of theta plus f naught cos pt minus theta sin of theta. अब एक चीज को देखो. सो व्हाई आई हैव रिटन दिस इन वन लाइन सो दैट यू कैन आल्सो आइडेंटिफाई दिस थिंग. ठीक है, अब यहाँ पर ना हम दो चीजों को करने वाले हैं कंसिडर. हम यहाँ पर सबसे पहले क्या लेंगे? हम लेंगे a ओमेगा स्क्वायर माइनस p स्क्वायर. इसको हम कंसिडर करते हैं. सो वी कैन से लेट a ओमेगा नॉट स्क्वायर माइनस ऑफ p स्क्वायर इज इक्विवेलेंट टू f नॉट cos थीटा. ओके एंड सिमिलरली एक और फैक्टर है हमारे पास, क्या है वो? 2r ap. ओके सो इसको हम कंसिडर करते हैं एंड 2r ap is equivalent to f naught sin theta. Let's call it as equation number second and let's call this as equation number third. Okay, दोनों को क्या करते हैं? Squaring and adding. Okay, so squaring, so we can say first square plus, not first square, so we can say second square plus third square. Let's take it as second square plus third equation square. So from here what we are going to get? A square omega naught square minus p square whole square plus 4r square a square p square is equivalent to f naught square cos square theta plus sin square theta. Correct? And cos square theta plus sin square theta, automatically it gives us 1 itself. Okay? So from here what we can say? So this implies that a square omega naught square minus p square plus 4 r square a square p square is equivalent to f naught square itself. So अब यहाँ से if in case we have to calculate the value of a will be equivalent to what? So that will be, so we can say firstly a naught square will be f naught square over omega naught square minus p square whole square plus 4 r square a square p square, not a square. So a square तो basically हम calculate ही कर रहे हैं. So we can simply say that it will be r square p square. Okay, so this implies A will be equivalent to F naught over under root of omega naught square minus B square whole square plus 4r square P square. Okay, so now we know one thing, since X is equivalent to A sine pt minus theta. That's what we considered also, correct? यही हमने solution consider किया था. यहाँ पर A की value को कर देते हैं substitute, which is F naught over under root of omega naught square minus P square plus 4r square P square, correct? And then as it is, we can say, so sine of pt minus theta. Okay, so since हमें एक चीज पता है that x was equivalent to x1 plus x2, if you remember, like damped simple harmonic oscillator के केस में, तो हमारे पास दो सॉल्यूशंस आए थे. एंड यहाँ पर जब अगर अब हम पोस्ट हार्मोनिक ऑसिलेटर की बात करते हैं, here x1 will be equivalent to, so we can say that will be a naught, or if you remember the solution that we are talking about, so we can simply say a naught e raised to the power minus of r. Also, basically it was e raised to the power minus of rt minus of rt sine omega t plus phi, correct? And so x2 was equivalent to जो अभी हमने consider किया, that means a sine of pt minus theta. Okay, so अब यहाँ पर what we can say is this factor, ये जो x1 है ना, so this is going to be equivalent to 0 with time. Why it is going to be equivalent to 0? Because हमें पता है कि जो amplitude है ना, that keeps on decreasing. ठीक है, सो एम्पलीट्यूड सेंसर और वी कैन से डिस्प्लेसमेंट कम होती जाती है, तभी तो हम उसमें पोस्ट हार्मोनिक ऑसिलेटर का, तभी तो पोस्ट हार्मोनिक ऑसिलेटर डोमिनेट करता है, isn't it? तो पोस्ट हार्मोनिक ऑसिलेटर का पर्पस ही यही है कि जब हमारा वी कैन से कि लेट्स कंसिडर एक पेंडुलम है, ठीक है, इस पेंडुलम ने जब मूव करना बंद कर दिया है, देन आफ्टर दैट तो हमें क्या करना पड़ेगा, और इन किसकी वजह से, तो दैट माइट बी बिकॉज ऑफ वी कैन से कि फ्रिक्शनल फोर्स की वजह से या किसी भी रीजन की वजह से, तब हमें एक एक्सटर्नल पीरियोडिक फोर्स लगाना पड़ेगा, सो दैट उसके बाद ये मूव करे विद कांस्टेंट एम्पलीट्यूड. ठीक है, इसका पर्पस ही यही था. So that's why what we can say that x will be equivalent to what? So this x will be equivalent to a sine pt minus theta, and that will be equivalent to f naught over, and we can say sine pt minus theta under root of omega naught square minus p square, then plus 4 r square p square, correct? ठीक है, तो this is going to be what? So we can say this is going to be the solution for damped post harmonic oscillator. Okay, after this, so let's talk about the concept of power dissipation. Okay, so if in case we talk about the concept of power dissipation, पावर डिसिपेशन बेसिकली हमारे पास होता क्या है, सो पावर डिसिपेशन होता है कि किस रेट से हमारा, सो वी कैन से रेट ऑफ डिसिपेशन ऑफ एनर्जी, रेट ऑफ कि हमारी एनर्जी किस रेट से डिसिपेट हो रही है, रेट ऑफ डिसिपेशन of energy is known as what? So that is known as power dissipation itself. So अब since energy का dissipation हो रहा है, so that's why we can call it as P is equivalent to minus of dE over dt. Okay, and since kinetic energy, अब यहाँ पर अगर अब हम energy की बात करते हैं, और we can also say average kinetic energy. So average जो kinetic energy होती है हमारी, so 1/4 m a naught square omega square, but this is going to be an ideal case. ठीक है, बट जब अगर हम प्रैक्टिकल केस की बात करते हैं, सो दैट विल बी इक्विवेलेंट टू 1/4 m a naught square omega square e raised to the power minus of 2 kt. Similarly, if in case we talk about the potential energy average, that is also equivalent to 1/4 m a naught square omega square e raised to the power minus of 2 kt. So from here what we can say, total energy हमारी कितनी हो जाएगी, total energy will be equivalent to 1 over 2 m a naught square omega square e raised to the power minus of 2 kT. So total case when so we can say this is going to be the total energy ka case when damping is absent is absent. Now, since energy is equivalent to E is equivalent to E naught e raised to the power minus of 2 kT. ये भी बोल सकते हैं. Okay, so from here we can say P power dissipation will be d over dt E naught e raised to the power minus of 2 kT. Okay, so अब यहाँ से इसका कर देते हैं हम differentiation. So it will be E naught e raised to the power minus of 2 kT then times of 2k. So this will be also equivalent to E naught e raised to the power minus of 2 kT times 2 multiplied by 1 over 2 tau. What is this tau? Tau is basically the relaxation time. Okay, so this implies we can say that power dissipation P is equivalent to E over, because ये 2 से 2 cancel out हो जाएगा. So we are left with P is equivalent to E over tau itself, where tau is going to be what? Relaxation time. So that means since we know one thing कि energy resist कर रही है. So and उसके लिए एक हमें क्या करना पड़ेगा so basically to overcome that एक resistive force को apply करना पड़ेगा. Correct? So which is why what we can say कि हमारे पास यहाँ पर जो हमारी power dissipation है वो हमारी किस किस factor पर depend करेगी. That is going to depend upon the relaxation time and energy के factor पर. Okay, so I hope this concept is clear to everyone. I hope this concept of damp force harmonic oscillator is clear to everyone now. So if in case you are having any doubts from this part, you can surely let me know in the comment section. And don't forget to like the video, share the video and subscribe to the channel, that is Engineering Insights Physics Series. So we'll meet you in the next video. Bye everyone.